Following on from the previous video, we were trying to find out the arc length and the speed of a parametric curve, and we got to this stage here where we said that a small change in time, we can make this statement. Now, a small change in time. Now, take the limit as time tends to 0. Then this delta t here becomes dt. So we can jump from here to here. So in the previous video, a small change in time we made this statement. Now take the limit as t tends to 0. Then this delta t will become dt. So we can jump from here to here. Now square root both sides. That will then give you this. Now times both sides by dt. That will then give you this. So what it's saying is that a small change in time, will result in the particle making this path, traveling along this path here. So a small increase in time would result, combine it with this whole thing here, then the result would be ds. So if you want to know, so ds here represents the actual path from here to here, because we've got a small increase in time. So if you want to know the whole arc length, so you've got a small increase in time would result in the path traveling from here to here, and then let's just say before that would be from here to here. Before that would be from here to here. And then from here, so from this bit here to this time here would result in the particle moving from here to here. Well, if you want to know the whole path, then you would sum up. You would sum up everything. So this ds. So let me start again. Sorry. So a small change in time, dt would result in the particle moving from here to here. If you want to know the whole path, then sum up the whole thing. So hang on. So the whole arc length is you really summing up everything. Okay, so this is a formula for the arc length. And if you want to know the speed, well, hang on, the speed was actually this. We've actually done the speed. So right from the start, we were here, and then so this is in the delta t realm, and then take the limit as t tends to 0. That will then take us to the dt realm. So from here we can jump to here, square root both sides. That will then give us this. You see, this here is the actual speed of the particle, because if you look at this, ds by dt, you've got ds by dt. If you look at the diagram here, hang on. ds is the actual distance traveled by the particle along the actual path. That is ds. But then if you've done this distance, if you've done a distance of ds in a period of time of dt, then ds by dt would represent the speed. So really we have the speed all along. The speed is given by this. Okay, the arc length is given by this thing here. Okay, by you summing up all. Well, the arc length is given by this, and the speed is given by this. Okay.